There we go. So we're starting off 2.4 lesson today, right? Measures of variation. And we're going to be learning how to find the range of a data set, how to find the variance and standard deviation of a population and of a sample, how to approximate a sample standard deviation for group data, and then last but not least, how to use the empirical rule to interpret standard deviation, right? An empirical rule is something you guys have learned in the past before. It has to deal with this bell-shaped curve. I don't know if you heard that term before, or the normal curve, but that doesn't go away, and that's actually a big part of statistics. All right, so let's start this off. Easy stuff right here. We're going to be looking at the very first part right here is calculating the range. Calculating the range of a data set. Okay, so let's take a look here. The range is simply the difference between the maximum and the minimum. So you take the largest number, subtract it from the smallest number, and that's your range, right? Easy, right? Easy. That's all you have to do to find the range of something. And when you calculate the range, you're seeing how much the data can vary from the smallest end to the largest end. How much does it change from one to the other? So let's do one real quick, right? A corporation A, hired 10 graduates. The starting salaries for each graduate are shown. Find the range of the starting salaries, and these salaries are in thousands of dollars. So this person right here, this person is making $41,000 in salary. This person next to him, who is also a graduate, is making $38,000 a year, and this one over here is making $39,000 a year, and so on and so forth. So to calculate the range, right? To calculate the range, all I need to do is simply find the max and then subtract it from the min. Right? That's all it is. The range is just the largest number minus the smallest number that you can find on here. So looking at these salaries, who's getting paid the most here at this company A, corporation A? Who's making the most bank at corporation A here? Let's see here. We got, I think it's going to be the, would you guys agree? I think it's the 40, not the 45. What am I doing? The 47,000, right? 47,000. This guy's making the most money at this corporation as a new hired graduate. That's the max I can see right here. Right? What's the minimum? Who's making the least amount of money at this corporation? I think 37 is the minimum, right? Is that right? I think that's right. That's the minimum. So what's the range at this corporation? How much can you make? How much does it vary? How much does it change from lowest to highest? Maximum number I see is 47,000. The minimum number I see is 37,000. So the range that you can make at this corporation varies by about 10,000, right? Varies by about 10,000. All right. Take a second here and see if you guys can do the second one. I don't have a pair deck for this part right here, but just go ahead and type it into the chat once you figure it out. What's the range for the U-try? What's the range for the U-try? Go ahead. I'll give you guys a second. Looking at the U-try, what's the range that we have there? $35,000. Good. And 35 is also a perfectly valid answer as well. Wait, is it really 35? Dang, that's huge, right? But yeah, if everyone else is saying it, it must be true, right? I don't need to do the work. You guys, no, don't do that. That's terrible. Don't just buy into the hype, right? Check the work yourself. But it looks like everybody's agreeing with 35, and it comes out to 35,000. Miguel, yeah, that's irresponsible. Calvin, that is true. You're gonna be the person who's gonna hold me true to this, right? The maximum number that you guys see, I believe, is 58, right? And the minimum number that you guys see is 23. Did I do that right? 58 and 23. Okay, so the range for this problem, I'm going to go ahead and do the calculation. The range of this problem. The range. What is going on, Nakmi? The range of this problem is going to be equal to 58 minus 23, which comes out to, I disagree, negative 35,000. No, it's just positive. It's the max minus the min, right? Always the max minus the min. Lewis is going, huh? Uh-oh, are you lost a little bit, Lewis? We're just taking the maximum minus the minimum number. 58 minus 23, that's why everyone's shouting out or typing out 35. And the reason why some people are saying, oh, no, I'm not. Okay, you're just saying, huh. All right, not yet. Yeah, so some people are saying 35,000 because, of course, this is in thousands of dollars. So one company has a range of 10,000. Another company has a range of 35,000. Which company would you work for, by the way, if you had this data, right? Let's say you got hired from Corporation A and you got hired from Corporation B. I'm going to ask in the poll right now. And use this simply, can you guys go into the poll? It's in the, if you type into the chat, click on the triangle, square, circle. I'm going to start a poll right here. Which company would you rather work for? Which company would you pick to work for, right? And would you pick for company A or would you pick company B? Right? Knowing this data, knowing that Corporation A has a range of $10,000 and Corporation B has a range of $35,000, which corporation would you work for? You don't have to tell me why, you just have to vote. Which one do you think is the one that you would go with? Okay? And that's something you got to think about sometimes. You actually, well, no, Brenda, go into the vote. Click on the chat in the Google Meet. But there should be a triangle, square, circle icon in the chat next to the chat bubble. And there should be a polls button. Go ahead and click on the polls button and you can go in there and vote. And it's just fun, you know, just fun to see. Which company would you decide to work for, A or B? Unless, of course, if you're typing in the chat to tell me why you're picking B, Brenda, that also works too. There's no, as of right now, I can't tell you which one is the right company to work for. But by the end of today, I shouldn't think. By the end of this this section, hopefully you'll be able to have more information to make a. The range is bigger, and that's a perfectly valid. You know, that's one of the things that we're looking at right now, right? The range is bigger, right? So maybe you would work there because you feel more competent that you'll get the higher value of the range, right? Right. That's one perfectly valid thing to look at, right? And you see that. One downside, though, with working at a place that with a high range is what if you're a slacker, right? What if you're a slacker or you're trying to do the least and they pay you based off of the amount of work you do? The minimum you would get paid then would be like 23,000, right? At that point, maybe it would be better to work at company A because their minimum is 37,000 and you could be a slacker there and get more money there. But of course, none of you are slackers, right? All of you guys are hardworking and you work for the max value, right? None of you would be working for the min. I laugh because I'm the guy who works for the min. I might not seem like it, but I like to take the easy way out. You know, work smarter, not harder, right? Get to the company that's going to pay you more, but without having you do the most. Which, by the way, unless you're working for yourself, don't work yourself like over hard at any company, unless it's your own company that you own. Okay? If you're working for someone else, unless you like love the job, I guess I shouldn't be saying that. Anyways, so that's just the first thing we want to start off with. I want you guys to start looking at when you start dealing with these problems is knowing the range. Is that enough information for me to figure out, do I want to work at one company or do I want to work at the other company? Which one is better, right? And that, of course, is not enough information. Honestly, that's not fair. But at least you can get a start to look at, should you start looking at Corporation A or Corporation B? All right. So in the last chapter, right, we learned how to calculate the mean and the median, right? The mean and the median. So let's take a look here. Looking at these two, and these are test scores, let's say. Let's consider these test scores from an AP Bio class at Lawndale High, right? So one class has 7 students and another class has 7 students, okay? And looking at that data right there, right? Which class did better? Class 1 or class 2, looking at the data there. And one thing that we learned in the last section was how to calculate the mean and how to calculate the median, right? And if you look here, the data are lined up for us, so the median is going to be easy to find, The median for this one is the number that's exactly in the middle, which in this case is 90. Over here, same thing. What's the number that's in the middle? It's 90. This is already going with the guess. I like that. He's saying that group 2 is going to look like it's doing better than group 1. But if you look at the calculation here, they both have the same median, don't they? They both have the same median. What about the mean? What about the mean? The mean for this group, well, this one's straightforward, right? I'm not doing any tables or anything like that. You just calculate it. Akarowan's already calculated it out. He's saying they're both the same. Let's show that. Let's show that. So the mean for group 1, right, is going to be 88 plus 88 plus 89 plus 90 plus 91 plus 92 plus 92. Gives me a total of 630. Divide that by 7, and that's going to give me a mean of 90 as well. And we're going to do this over here. This has a mean, and same thing, right? This one's not a table. Plug it in, and you get 630 again, right? Add it all up, divide that by 7. That's also going to give me a mean of 90. So I have the same mean, and I have the same median for both groups, right? For both groups. But Lewis, you felt pretty strong about saying group 2 is doing better than group 1. Something must have stuck out to you. Is there a reason why you went with group 2 as opposed to group 1? And if anyone else out there wants to chime in, that's perfectly fine too. Which one would you think is a better group based off of these scores? You never said that? You just said 2. No? Or you just typed in a 2 randomly? Oscar's going with 1. Range is different. Range is different. Yeah, they are different. The ranges are different, aren't they? The range for group 1 looks like it's smaller than the range in group 2. Right? That's a good observation. That is a good observation. That's good. Anything else? Oscar's saying group 1. You have a reason why for group 1? Or are you agreeing with that? More consistent in group 1. Yeah, I like that. Miguel, you didn't hear me say the wrong word. I'd rather take a B plus than a C. Oh, so now you're taking into account. So you're also looking at the range as well. You're looking at the lowest value, right? Right. So group 2, right? Group 1 is a little more consistent. Man, my dyslexia is kicking into high gear today. A little more consistent, right? A little more consistent, right? My vocabulary is not consistent, I can tell you that much. Group 2, right? What's the plus side though? Even though group 2 has like a wider range, what's the plus side? No mistakes though. Yeah, it's all on purpose, Miguel. All of it on purpose. All for the sake of learning, right? Group 2 has scores in the high 90s though, right? Would you agree? Has scores in the high 90s, right? So again, if you're one of those people who are like aiming for like that perfect, maybe group 2 would be considered the better one because you see yourself as one of these people, right? Which, by the way, this is still A's. I don't know why some people like don't validate that as in like a valid A. They're like, it's a low A. It's still an A, by the way, right? Now this is the part where we start to discuss like, well, how do you then decide? Like, if I was trying to hold a pizza party for one of these classes, right? And it would be based off of which class did better than the other class, and they got the same means, right? And the same medians. How would I pick if I was trying to hold a pizza party for these classes? If I was trying to hold like, oh, class 1 should get a pizza party, or should it be class 2? Or should I just split the difference and say both of you guys get a pizza party because you tied? And I can't do that because I'm a teacher and we don't make that much money. Yeah, why not both? I don't have the money just to have a pizza party for both classes. That's too much money. Students first. I mean, if everybody chipped in $5, I think maybe. All right. So what? We don't make money though. That's true. But we can all help together, right? We all help together. All right. So back to this focus right here, right? How do I know which one is better than the other? There's other things that we need to take into account when we start measuring this, and that's what this chapter is about. is trying to see, can we go into this even further to measure which class is better than the other, right? And the range is a good place to start, but it's not enough. The range is a good place to start, but it's not enough. And let me show you what I mean, right? Let's say some company has a range that varies at $5,000, right? And let's say it's the same for each one, but check this out. Let's say someone was working at like a small garage, right? Just to think, all I can think of right now is Pay 'n Spray at, like, if you guys ever play Grand Theft Auto. Right, let's say there's a NPC who works at a Pay 'n Spray, which is like in the game like a body shop place for your car. Okay, and the person who works there, right? And this is a side note. You don't have to write this down. All right. This person who works there makes $25,000 annually. Right. This guy makes $25,000. Right. Don't write this down. Let's just take a look at this guy. Let's say this worker who works at a Pay 'n Spray. Right. This worker here, worker A, he makes $25,000 a year. Okay. And then worker B, who does the same exact job, by the way, who's worked there as the same amount of time as him, right? He gets paid $30,000 a year, right? The difference there is $5,000. Would you say that that is a big difference or a small difference? They do the same job. They work there the same amount of time. One guy gets paid $30,000, the other guy gets paid $25,000. Calvin's already started off. That's a big difference, right? Mariah's saying it as well. Big difference. Come on, saying big difference, right? So here's the thing. Range is a nice start to look at. This is a range of 5,000, but here's the thing. Let's say we looked at another job, right? This guy works at I don't know. This guy is these guys are into, I don't know. Oh, this is going to be inappropriate. You guys are in drug dealings, right? Drug dealer A, so inappropriate. I can't think of anything else right now, so let's just go with that, right? So drug dealer A. Oh God. Okay, drug dealer A makes. All right, just follow through. We're not looking at the actual jobs. We're just focusing on the money part, right? So focus on the stats part of the money. All right, so let's say drug dealer A, he makes, you ready for this? Let's say he makes $700,000, right, in a year, right? Edit this out, yeah, hopefully, right? So that's drug dealer A. He makes $700,000, right? A partner, right, who's also a big-time drug dealer, but they work together, right? This guy makes $705,000. They both sell the same amount of drugs. They did the same amount of work, right? They're both at the same level of drug dealing, whatever that may be, right? One guy made $700,000. The other guy made $705,000. Now, here's the thing. Would you say, now this has the same range, right? This is still a range of 5,000. But when you look at this value for the drug dealers, is $5,000 a lot? Is $5,000 a lot? It's small now, right, Oscar? Right? It's small. But Calvin's saying 5K is still 5K. And you're right. It's still 5K. And of course, I shouldn't have picked drug dealers because drug dealers will kill people over 5,000, I'm pretty sure. But I feel like, no, you know what? Let's not go with drug dealers. That's just going to come off weird. I can't think of anything else that makes like a lot of money. Zookeepers, investors, lawyer. Let's go with lawyer. Let's go with lawyer. Let's go with lawyer. That's a little bit more sound, right? So real estate. Oh man, you guys are so much better at picking doctors. Why do I go with drug dealers? Anyways, lawyers. Let's go with that. Lawyers, right? So lawyer A makes $700,000. Lawyer B makes $705,000, right? And the range is still only 5,000. But as Calvin was saying, $5,000 is still $5,000. But in a sense of just looking at these values right here, right, at 700,000, right, at 700,000. No, Lewis, no. Then I'd be able to afford pizzas for all of you guys, but I can't. But yeah, it's a smaller percentage, right? You're looking at it and you're comparing it to the values that are there. Yeah. So $5,000 here is still a change. It's still a difference, but it's not a big difference, right? But yet it's a pretty big difference when you're dealing with these guys who are working for this amount. So what I'm trying to say is when you're trying to measure something, the number in the difference itself, the range itself, is not good enough, right? You have to compare it to the numbers that you're working with, right? The data values that you're dealing with, right? $5,000, by the way, would be a big difference for people who don't even have a job, right? One person gets paid maybe like $0 and another person gets paid maybe $10, right? And you tell them like, hey, they're going to get, one person gonna get $5,000 more. That's going to be a very big difference, right? $5,000 there is a huge difference, right? Compared to someone here. That's also a big difference, but it's not as huge as this one. And it all comes down to looking at your data, right? And that's what this chapter is about, looking at that data and calculating the difference between your data and this deviation. How much does it deviate from a average? And that's what we're leading up to right here, right? We need to find a way to find out and measure what's a way to see if something is a bigger deviation or a smaller deviation. And we do that by looking at a standard deviation. When you calculate the standard deviation, it's a standard that you measure by to tell you, you know what? This has a standard deviation of this amount. The larger the number is, the larger the difference is in relation to the data that you're working with, right? And that's why we deal with standard deviation. The purpose of that coming up is to help you to measure, this data looks better than that one. It has a smaller standard deviation, or it has a smaller range compared to the others. And that's the whole purpose of this right here, this standard deviation. It's a standard to help us to measure, right? And it is actually a very big tool and a very big important value to look at when you're calculating the standard deviation. Okay, so that's something to keep in mind. But what exactly is the deviation? And the deviation is simply, and let me just explain this to you right here. The deviation is how much your data changes from your average. So you have a bunch of data, right, that you've collected from all the people who ever worked somewhere or do something and have all this money. You can calculate how far away someone is from the average. And when you do that, that's just the deviation. The deviation is just your data point minus your average. Okay. By the way, hopefully you guys have started writing down these symbols. And if you haven't, I suggest you start now, right? When you deal with X usually has to deal with your data point or your data, right? Data, right? It's one of your data entries, right? That's all X is. When you look at X bar, right? X bar is your sample mean, and your mu, this fancy M, is your population. Population mean. So get these symbols down, by the way. You do have to know these symbols. You do have to know what X represents. You do have to know what X bar represents. And you do have to know what mu represents. So that is going to be part of it. So when you see the symbol like mu right here and this X bar right here, you need to know like, oh, that is the mean of the population, which is right there. And you have to know that X bar is the mean of the sample, right? So you guys got to start knowing those ones down, getting those values down. Okay. With that being said, this next part, these are equations, and you don't have to memorize these equations, but you do need to know them. So I would suggest you have them written down somewhere, or I will provide them to you. But the hard part about it is you need to know what the symbols represent. Okay, you need to know what the symbols represent. So when you're calculating variance and standard deviation, these are the symbols that we use. And it depends on if you're looking at the population or if you're looking at the sample. Remember that in chapter 1, we had to tell the difference between population and sample? It doesn't go away. You still need to know how to calculate, or what you're dealing with is a population, or what you're dealing with is just a sample. If you're dealing with a sample, we use the letter S for the variance, the sample variance. S squared, right, represents the sample variance. And with that, that gives you this equation right here, right? This little O with a line is called sigma. It's called sigma. So this little O with a line squared represents your population variance. You guys see the difference there? Variance. They're both variance, by the way. They're both variance. Oh, wow, I spelled variance wrong over here too. Variace, variance, right? They're both variance, man. Yeah, they're both variance, but one is for the population and one is for the sample. And all variance measures is basically how much your data varies from each other, right? The larger the variance, the more your data is all over the place. That's all that is, okay? And the way you do it is you do it with this crazy looking equation. And I know this looks crazy because I've seen it before, and it's just this, it's like, what the heck is going on here? But remember, in the last chapter, I had you guys calculate the average by doing it piece by piece and then summing it together. That's going to be very similar here. Instead of doing the average, though, I'm going to be doing the variance. Right, I'm sorry, the deviations. And then we're going to square them, and then we're going to add them all up. And you're like, what are you talking about, Naki? And I'll show you when we actually get into the problem and we start doing it. It looks more complicated than it actually is. But for right now, I would just want you to understand these symbols, first of all, okay? So X is your data point, whatever your data point is, right? Mu is your population mean. And if you look down here, we use X bar because it's a sample mean. Okay, so get those symbols down. I have them written up here. X is your data point. X bar is your sample mean. Mu is your population mean. There's a couple more, though. You also need to know this guy. Sigma squared is your population variance. S squared is your sample variance. Of course, though, within that, there's a few more things you need to know. I know, I'm like throwing all these letters at you. Sigma by itself, without the low squared, that represents your population standard deviation. This is the big one. Your population standard deviation is just the little circle with the line without the two there. We call that the sigma by itself. And if you're looking at S by itself, that is the sample standard deviation. I abbreviate standard just because I'm too lazy, but you could write out the whole word. All right, so these are new symbols that I hope you guys write down somewhere, and you will learn them over time. You have to know them, but this is just us starting it off, okay? Okay, so these are the equations that we need to use to calculate variance and standard deviation. And I know they look complicated, but basically if you find out what the variance is, the standard deviation is just the square root of that. So whatever answer you get for the variance, the standard deviation, you'll take the square root of that number. I know you're like, my God, what the heck? And I agree. So we're going to do this piece by piece, very slowly and very methodically until you get how to do it. If you don't understand what it is you're finding, don't worry about that just yet. Just worry about getting it first. And then we'll focus on what it is you're finding after we get them. I know that sounds unintuitive, but that's just one of the ways that makes this a little bit easier to deal with, because I'll be honest with you, right? Looking at this equation, when I first saw it, was very daunting, very like, what the heck is that? But once we do the problems, you'll see it's not too bad, right? It's not too bad. So let's do a problem here. Let's do a problem. I'm going to start up a pair deck so you guys can work along with me when we do this problem. And it actually will help if you guys work along with me. So let me go ahead and get the link here. I'll put it into the chat. There's the link. All right, if you want to do it on your phone, you can. But this is actually going to be, this is one of the ones that's actually a little bit harder on your phone because the table is a little big. So if you want to do it on your phone, just be careful. You can still type into the table, but it's going to be a little bit annoying. All right. So for you guys, you guys have a nice table there to do the standard deviation. I'm going to have to draw my table out. So let's take a look here. So to calculate your standard deviation, right? This, by the way, what we're working with is, I believe this is a sample, right? Is this a sample or is this a population? Let me take a look here. Let's see here. For example, a corporation hired 10 graduates. Find the range of the starting salaries. Is this all the workers? I think this, the way they say this, find the standard deviation of the starting salaries. I think this is all the graduates at corporation one. So since this is all the graduates here, I would say that this is the population, right, of all the starting salaries at this corporation, because it doesn't say anything else otherwise. It just says back at right here at the top here for corporation A, the starting salaries for each graduates are shown. So these are the higher, this corporation has hired 10 graduates. So I'd say this is a population of graduates who are working here, right? So since I know there's a population, the symbols that we're going to be using now, right, is mu for the mean, right? Sigma S for the variance, right? And sigma itself for the standard deviation, for the population standard deviation. So how do I calculate these guys? To calculate this, right? To calculate the variance, sigma squared, you have to use this formula, which is from above. Let me write this down so we can take a look at it. It's going to be this guy right here, the summation of x minus mu squared over capital N. And sigma itself for the standard deviation is going to be the square root of that said answer, x minus mu squared over N. And this looks crazy, but let's do it piece by piece. How do you know what formula to use? So this one was a bad example, Michael, right? So it's either going to be, if it's population, it's just all of this to calculate your variance and your standard deviation. If you know it's a sample, then it's going to be all of this for your variance and your standard deviation. But this particular problem, it was a bad example because it doesn't state it doesn't state clearly if it's a population or if it's a sample. I'm just telling you right now, just from my experience, that I would consider this a population because I'm assuming that this company only hired 10 graduates, and we're looking at the standard deviation for all of their graduates that they hired for that year. So that would make this a population. If it had said that they sampled 10 graduates out of their recent hires, then I would say that this is a sample of standard deviation. I would use this equation down here. But for right now, just for us to practice, we're going to be using the population variance, just for practice, Michael. So we're going to be using this equation up here. Okay, hopefully that answered your question. I know it seems like weird voodoo that I just picked the top one up as opposed to the sample, but that's just because the wording on this is poor. I should have stated that this is a population in the question itself. What helped me say it's a population is just the fact that we're only looking at the 10 hired graduates, so I'm assuming that we're looking at the new graduates only, and that's going to be the population that we're focused on. Okay? All right. So with that being said, let's take a look here. And here's how I want you to start off on your tables. You see your tables that you have there? Right? First thing I want to list out on my table is going to be my x values. My data points. So for the tables that you guys have, right, at the very top, can you guys put this in there? The first one that I'm going to put in here is going to be the x values. Okay? That's going to be in the first one. So I take these numbers, I just write them down. So this one right here would be 41, right? 38, 39, 45, 47, 41, 44, 41 again, 37, and 42. Are you guys able, did I put enough into your table? Is there enough space there for you to type out those numbers in there? I hope so. So the first one at the very first part of it, can you guys put an X at the very top of there? Is there enough? Oh shoot, that thing goes in the way, doesn't it? That stupid little icon where it says you can draw anywhere on that slide. So maybe you can't fit the X in there. I'm looking at you guys' screen, so it looks like you guys are able to. Lewis, I am deeply impressed that you're going to try to do that by just drawing that out with your mouse instead of just typing it out. I am impressed if you want to do it that way. Calvin, trying to get the numbers to line up perfectly in those boxes. I'm a little upset. Why the heck are those boxes not fitting in there? I can type it. Yeah, you can type it. Notice, you can write it out by hand too if you want. There's only 10 people in here, by the way, out of. Yeah, I just realized that stupid thing at the bottom there is in the way. Failing 10, we have been suffering. I thought you knew, Lewis. I thought you just wanted to write it out. Again, though, there's only 10 of you guys in here, but there's clearly 31 students in class right now, right? Which, by the way, some people have left. Get in here, guys. Come on. You guys got to practice this with me, or else it'll be way too difficult to do this on your own. You're going to get lost, I promise you. So follow along with me. So let's get those numbers in there, right? Let's get those numbers in there. I shouldn't have put the table in. Maybe I should have just made it blank and you guys could type in the numbers. Oh, well, future sake. I feel a little bad. I feel a little bad. So just try your best. It doesn't have to be perfect. Yeah. Oh man, I did this for the second slide too, didn't I? I did. Ugh. All right. So, oh, that's gonna suck. All right. So, sorry guys. So take a look here. What you just done is wrote down all the x values, right? And that's this part of the equation. Do you guys see this part of the equation right here? Right? And look at that part of the equation. It's the x value minus this thing called the mu. And the mu is the mean, right? That's all the mu represents, is the mean. So what I need to do next now, right, in the next column, I need to find the x value minus the mu. But the mu, of course, is just the mean. That means I have to find out what the mean is. Well, luckily for us, we did a whole chapter on how to calculate the mean, right? And the mean is just all these x values added together divided by how many there are. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? I have 10 numbers here, and I'm just going to divide by 10. So I'm going to sum these numbers up and divide by 10 to see what is the average salary of company A, of corporation A. So I have here 41 plus 38 plus 39 plus 45 plus 47 plus 41 plus 44 plus 41 plus 37 plus 42. Right? I get there. 415. Right? I'm going to divide that by 10 because there's 10 numbers involved. My mean for this problem is 41.5. Right? 41.5. So here's what I need to do for everything in this column right here. For this column right here, I need to take 41. That's not my marker. That's my highlighter. I need to take this answer right here, which is 41, which is the number that I have in this data point, and I'm going to subtract it from 41.5. This 38, I'm going to take this 38, I'm going to subtract it from 41.5. This 39, I'm going to take that 39 and subtract it from 41.5. And what I'm essentially doing is I'm finding this thing called the deviation. How much does each of these data points are far from the mean? How far away is each of these data points from the mean? Right? That's essentially what I'm doing here. Right? So 41 minus 41.5, it's below the average, and it's below the average by about 0.5. 38 minus 41.5, 38 is below the average, and it's below it by whatever 38 minus 41.5 is. And we're going to do this for all of them. 45 minus 41.5, 47 minus 41.5, 41 minus 41.5, 44 minus 41.5, 41 minus 41.5, 37 minus 41.5, and last but not least, 42 minus 41.5. Are you guys okay so far? This is a lot. This is a lot, I promise you. This feels like a lot. And it is. And it is a lot. So we're going to go through and we're going to subtract these guys, okay? We're going to go through and we're going to subtract these guys. So hopefully you guys are doing all right. You're following along, and you can just screenshot this and paste this into your notes from the Pear Deck. Miguel's doing a pretty bang-up job of trying to get those lined up. That looks pretty good. Lewis, I see you found the typing feature. I don't know, man. I kind of appreciated your handwriting a little bit more. But, you know, looking good, looking good. Michael, nice job getting it to line up as best you can. Kevin, same to you. Calvin, that looks ridiculous. That's awesome. I did find it. Brenda, good job. Good job. That looks beautiful. Jared, looking good. You have half handwritten, half typed. I like it. Oh, Patricia, you actually copied down my notes part of it onto the side. That's awesome. That's awesome. Demaya, looking good. Giselle, looking good. Keep going. I have 13 of you guys doing this, by the way. 13 of you guys who are in here doing it. Please get in there. Work this out with me. It helps. It helps. So let's go ahead and do these calculations now. So I plug this into a calculator to see what this is going to give me. I actually calculate all these. I'm supposed to have been calculating all these. In the future, you actually don't need to write this out. You just have to write down the answer, right? Give the 13 extra credit. Do I need to start doing that? Maybe I should. For the people who are doing the Pear Deck, I give you the Pear Deck extra credit. Y'all take that into account, Lewis. 13 who are doing it, maybe 13 get the extra credit. You know what? That wouldn't hurt. I might do that. So when I record this down, I can go back and record it in and put that in. That credit towards my calc grade. Calvin, I can't do that. You know that. What is your calc grade? Your calc grade is probably fine. All right, we'll take another test. Bring your calc grade right up. All right, so let's do these calculations. So first one up is 41 minus 41.5, which is negative 0.5. And I write that down. Negative 0.5. And what I was saying is, watch these people join now. Still at 13. Miguel, I don't know what the heck's going on. Where's half the class? But maybe it's because they're lagging. So that's the other reason why I don't force people into it, because maybe Pear Deck has always been something that lags for them. I'm not sure. It's possible. Put in there just in case. Maybe they're not there. Anyways, so what I was saying, right? When you do this in the future, you don't need to write all this down. You can just write this part. Okay? You don't need to write down 41 minus 41.5. You can just write the 0.5. Does the 0.5 go on the other row? No. It's supposed to be in the same row. All right? Jasmine's doing it in her notes. That's fine. See, so that's why I don't want to mark people off. Some people are just doing it in their notes. Okay, so this is still in the same column, right? This is still in the same column as it is right here. I don't know if you guys can fit that, but you probably could. But that's what I'm saying. You don't need to write this in the future. You could just write down the answer of what they're subtracting. I'm just showing where I'm getting these values from. So the next one up would be 38 minus 41.5, right? And that's going to give me negative 3.5. The next one up is 39 minus 41.5. And that's going to give me negative 2.5. And we're just going to write all these down. Negative 2.5. This is going to be positive 3.5, I believe, right? 3.5. This one over here is going to be 5.5, I believe. Next one after that is going to be negative 0.5. This one right here will be 2.5. This one right here will be, again, negative 0.5. This one down here will be negative 4.5. And this one down here is 0.5. So I'll give you guys a second to copy that down. All I essentially did was just actually did the subtraction, right? Just the actual subtraction that is given to me there. So 41 minus 41.5 is negative 0.5. And you just plug it into a calculator and you see what you get. And that right there, right, this part of the table is called the deviation. And what you've essentially found, right, when you subtract x minus the mean all the way down to here, what you've essentially found is this guy right here, x minus mu. You found that part. Okay? All right. The third table, I don't know if you guys can see this, but the third table is going to be this last part right here. If you look at the equation, we have x minus mu, right? X minus mu is what you guys see right here, right? X minus mu is right there. What has to be done after you do x minus mu is that little 2 right there. Do you guys know what that little 2 represents? That little 2 means you take that number that you just found, right? You take that number that you just found and you square it. You take that last thing that you just found and you square it. Okay? So this right here, this negative 0.5, what I'm supposed to do is take that number and I square it, right? Plug it into your calculator and see what you get. So with parentheses, by the way, negative 0.5 squared gives you this, which is 0.25, and I write that value down, 0.25. And I'm going to do that for all of them, right? So this one right here would be negative 3.5 squared. I go into my calculator, I type that in with parentheses, negative 3.5 close parentheses squared. By the way, the negative button on your TI calculator is this one down here at the very bottom next to the period. Do not press the subtraction sign or else you'll get an error. Okay? Do not press the subtraction sign, you will get an error. So the negative sign is down here because these calculators are prehistoric and they don't understand the difference between the two. So this right here is going to come out to be 12.25. Same thing with this one. This will be negative 2.5 squared. That's going to give me, see what I get, parentheses, negative 2.5 squared. I get 6.25. That's this one right here, 6.25. And I'm going to do that for all of these, right? So I'm going to do that for this next one. Do that on the calculator, and I get, oh, that's the same as the 3.5 up there. So that's going to give me 12.25. This next one down here, 30.25. This next one over here, 0.25. This next one over here, 6.25. And again, if you're having trouble seeing this, all I'm doing is taking the number that's in this part next to it, and I'm squaring it. I'm plugging it into my calculator and I'm squaring it. So this next one right here is supposed to be 5.5 squared. This one right here is going to be negative 0.5 squared. This one's going to be 2.5 squared. I'm just getting lazy right now, and I'm just not writing it all the way down. I'm just actually showing the answer here. I'm just squaring them on my calculator. So negative 4.5 squared is going to give me 20.25. And last down here, 0.5 squared is going to give me 0.25. I'll give you guys another second to copy that down. So I know this doesn't make sense on why I'm subtracting this number from this one and why I'm squaring it, but that's what I kind of want to show you guys after you write it down. It comes down from the formula, and let me show you. Let me show you that once you get done copying this down. Okay, once you get done copying this down, I'll show you this. Some of you guys are still copying it. And once you have the copy done, some of you guys might understand where I'm going to go with it next. And I'll show you in a second. All right. You ready? After squaring them up, don't you add the numbers you got all up? Yes, Demaya, yes. How'd you know that? Yes, that is right. You do add them all up. Have you done this before? Or better yet, oh, you're saying yes? Oh, I was going to say, or better yet, you are reading the problem. You're reading the problem. Check this out. Check this out. Look right here. What you've essentially done, right? What you've essentially done, when you took those numbers and you subtracted the two, you found this guy right here. When you square them, you've essentially found this part and you squared all these numbers. But Demaya is already on this last part. You add them all up, and that's this symbol right here. You see that E, that weird-looking pointy E? We talked about this before. That weird-looking E stands for the sum, right? It's the sum of all these numbers, and we did that. We did this already in the average, right? Do you remember? It was the sum of your weights, or it's the sum of your X times W's. That little weird squiggly sign tells you to look at this thing that you have right here and sum up all of these numbers, right? You take that and you add them all up. Right? And if you add all these numbers up, right, you'll get this thing right here, which is the sum of x minus mu squared, which is the sum of all these. And if you add all those numbers up, correct me if I'm wrong, I think you get 88.5, right? You get 88.5 if you actually type all these into a calculator and add them all up. 0.25 plus 12.25 plus 6.25 plus 12.25 plus 30.25 plus 0.25 plus 6.25 plus 0.25 plus 20.25 plus 0.25. Add those all up, and yes, we get 88.5. And this is why I'm like a little excited here. Check this out. What you've essentially done, this 88.5, let's put that in a nicer color. Let's go with orange. This 88.5 represents this whole thing. The reason why I do this table is it's easier to organize it. That's what that whole thing represents, is this whole table of work. So when I'm trying to calculate the variance of my population, I simply just write down the work that I have here, which is 88 divided by n. And n, I need you guys to see, I should write this off on the side somewhere. N is equal to the population size, or in other words, how many data points do you have in your data set, right? And in this case, my population size, my n, in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My n is, wow, my n is equal to 10. So for my standard deviation, I'm sorry, not my standard, for my variance, it's just going to equal to 88 divided by 10, which is 88.5. I'm sorry. No one caught that, huh? Or you're just like, Knock Me will catch it. He knows that he's doing that on purpose. But yeah, so anyways, 88.5. So my variance, I should say, not my standard deviation. What I've just found is my variance, because that's the symbol I'm using right here. My variance is 88.5 divided by 10, which is 8.85. And that's my answer. That is my variance. That is, of course, not what's being asked from this problem, is it? That is, of course, is not what's being asked from this problem. What is being asked from this problem? I'm asked to find the standard deviation. Does that mean I have to do all this work again? I hope you say no. You've done all this work already. You found it right here. To find the standard deviation, right? If you look, what's inside the square root is what you've already found. So all I have to do to find the standard deviation is take the square root of my answer that I just got up here, which is 8.85. So my standard deviation of this population is going to be the square root, second square root of 8.85. So my answer for this one is 2.9. Standard deviation is 2.97. 2.97. If you really wanted to, you could go further and write down more decimal places. I would go to no more than 4. So if you wanted to, you could say it's 9749 if you wanted to go to. But that right there, that is your answer. That is your standard deviation. That's your standard deviation. That is what you're trying to find. That's your answer. And that is, like I said, it looks like it's a lot of work. And it is a lot of work. There's got to be an easier way. Right? There's got to be an easier way. And there is. And I get to show you that easier way. So you're saying, Nami, why did you show us this ridiculous way then? It's to make you appreciate it. And plus, some of you guys actually had to do this already in your IM2 class. And I'm pretty sure that's where you saw this, right? From your IM2 class? Or was it your IM3 class? I forget. But actually, it could be IM3. Do you remember where you did this? Was this last year? If your teacher made you do this last year, your teacher was a little cruel. I'll be honest with you. Statisticians rarely calculate the standard deviation by hand anymore. In fact, on my test, I used to as well, and it was very mean of me. Financial algebra. Oh, you guys had to do it in there? Oh, man. Yeah, that sounds about right. That sounds about right. Yeah, that one for sure will have you calculate it. I don't know why he made you do it by hand, though. Or did he show you by hand, and then did he show you a shortcut afterwards? Because that would make it a little bit more exciting. Hopefully he showed you a shortcut. Because I'm going to show you a shortcut. Nope. All right. Let me show you a shortcut for this. Because honestly, I don't care about doing it by hand to get the answer. What I honestly care about is you understanding what is the standard deviation. Do I screenshot the work to post on the notes? Yeah, I would post screenshot your work on the Pear Deck and post that onto your notes. That would make it easier. But yeah, that's what I would look at. But here's the thing, calculating the standard deviation, it's a pain in the butt. It's honestly though, but if you look at it though, what's the beauty that's behind this that you actually get to see this happen is this value of 2.97, right, tells you if something is far or close to the average. You remember earlier when I told you, hey, is $5,000 far or is it close? And in the first one, you could see that it was really far for the people who worked at the Pay and Spray, right? Pay and Spray, right? But $5,000 was not a lot when you looked at the lawyers, right? $5,000 was not a lot when you look at the lawyers. And that's what the standard deviation is. If you can take that into joke. No. We'll edit that part out, Calvin. So what the standard deviation helps us do is, now that I know that my standard deviation for this problem is 2.9, I can actually say 2.9 is a way to measure if something is far or close compared to the data that you're dealing with. So let's see here, this problem, right? We worked this out. We found out that the mean for this problem was 41.5. The average salary that this person works at this company is around $41,500. $2,500, right? With the standard deviation of 2.9, right? Nice. Of 2.9, I can tell you if someone makes a lot more money than someone else. Meaning, if my standard deviation is 2.9 and someone makes $6,000 more than someone else, right? With a standard deviation of 2.9, $6,000 is a lot of a big difference for this company, because 2.9 represents $2,900, right? $2,900. So if someone was making only $3,000 more, it's reasonable. It's a little further, but it's reasonable if they make $3,000 more or less than someone, because it's really close to the standard deviation. If they're making $6,000 more, that's 2 times the standard deviation. That's going to be considered further away. That's a little bit more money. That's like not a lot. It's not a little bit, but it's not like a ridiculous amount. It's still a lot, but it's not a ridiculously large amount. Now, if someone was making $9,000 more than someone else, right? Looking at this, you'll say that $9,000 is a big difference here compared to someone who is making like, a lawyer's salary. But that's the deal. That's the idea behind the standard deviation. Once you get this number, you now have a way to measure to see if someone is making way more money than someone else, or if they're just making a reasonable amount of money more than someone else, right? And this is actually a big thing, and it's actually used a lot. And it's actually used by people who aren't actually in the field of business right now. If you ever decide to go into a job where you get to argue for your salary, and that's not the word I'm looking for. Shoot, I should know this word. When you go into the business world, right? You and they decide to hire you, you get to, can't think of the word. You get to talk to the people in HR and I can't think of the word. This is gonna bother me. Not argue for yourself. Negotiate. Thank you. Oh my God, Calvin, coming in clutch there. You can negotiate your salary, right? Why can I not think of that word? But that's the big deal. You can negotiate how much you make at a company, right? But of course, you need to try to sound reasonable, or else they're not going to hire you, right? You need to give them something to work with, right? So if a company is looking to offer you, you're just testing us. No. That time I was like drawing a blank on that word. But here's the thing. Let's say you go to a company and you find out the average pay for someone starting there is $45,000, or in this case, $41,500, right? You know that the average pay for the starting person is $41,000, right? But you want to get offered more, so you negotiate something higher. But you don't want to negotiate too high, because if you negotiate too high, they won't hire you because they don't have the money to afford you. But if you negotiate too low, then you're selling yourself short and you're not making as much money as you can, right? So if you know that the standard deviation is 3,000, you want to stay within a reasonable range, right? So if the average is 41,000, you want to ask like 44,000, right? You could go to even a little bit higher, to maybe 45,000. But you don't want to go to like 49,000 or 50,000. You can actually negotiate your salary. Yes, Michael. Not as teachers though. We get fixed salaries. So I didn't actually go through this process, but I have friends who worked in the tech company, and they are able to negotiate their ones. I have one friend from high school who ended up working at Symantec, which I don't know if you guys know that company or not. Norton Antivirus. Actually, I don't think you know that anymore, because I don't think they do Norton Antivirus around anymore. Anyways, when he got hired, he had to negotiate how much he wanted to get paid. And at that time, the average salary was $70,000 starting, right? $70,000, which is a lot, right? But of course, he found out what the average was overall for starting salaries, and then he calculated a standard deviation, and he wanted to sound reasonable, but he wanted to get a little bit more money. So he went with like $74,000 starting. And he's always like looking back, like he probably should have asked for more, because that person in HR was like, yep, we can do that. And they hired him, and they paid him at $74,000 a year. And I was like, that's nuts. This guy just got out of college and he's making $74,000 a year already. Just to give you a frame of reference, a teacher first year starting out when you get hired makes about 40s. Well, at least when I was working, I was making $45,000 a year. So he was making way more bank, and it was like exciting because, he just got out of college. It was nice to see. Also, another frame of reference. Before I got my teaching job, I worked a office/warehouse job where I got paid $15 an hour. And if you want to break that down salary wise, it's about 30 something thousand dollars a year. So yeah, there's different companies where you can negotiate your salary, and you should take into account, if you know how much the average is and what the standard deviation is, you can try to negotiate to a higher market value and still be not sound crazy doing so. What's my salary now? You can look it up, Michael. I'm not going to tell you what it is just because I honestly don't know the exact dollar value. It's not top secret, Lewis. All teachers are on the same pay scale. I'll tell you right now, I have a bachelor's and I've been working at Lawndale for 8 years. So you can look that up. You can look up the salary for our district, look at how many years I've been working, and look at my my degree. I have a bachelor's degree with a clear credential. So you can look it up on the chart. And it's something that you should actually do. Using information like this will help you to figure out, what would be a reasonable pay for yourself. So that's something you can do. Some teachers get paid differently depending what their degree is and how long they've been working for. And that's the bigger thing, is how long they've been working for. The longer they've worked for a certain district, the more money they'll make. And also if I searched it. Okay, that's just wrong. $563,000 a year. That would be great, but that's not right. That's not right. But yeah, you can look it up. Anyways, that's the idea behind the standard deviation. It's a tool. That's all the standard deviation is. It's a number that just tells us is something far or is something close, considering the average that you're looking at, right? Or the numbers that you're looking at. So I'm going to show you a shortcut next time. Right. Today I showed you the bare bones. This is how we calculate it by hand using a table, right? And this isn't too bad if there's only like 10 data points, right? But could you imagine doing this for 30 data points, right? For 30 data points, I'd have to do this with 30 numbers on my table and then subtract the number 30 times and then multiply them by itself 30 times, then add up all 30 numbers. And that's just nuts, right? In fact, when you start dealing with populations, we deal with this like thousands of times. But there's shortcuts for this, and there's tools that will calculate this for you, so you don't have to do this by hand. But I needed to show you where this comes from, so that when we start doing this, it's not just some magical number that comes out of thin air, right? It's a number that takes into account all your data points and to see how much those data points differ from each other. Okay, and that's going to be it for today, guys. I'm going to stop here. I know we only got to this part, but it's a meaty chunk, right? It's a meaty chunk. And if you want to practice, I don't suggest you practice calculating the standard deviation just yet. What I want you guys to do before I see you guys on Thursday is I want you to memorize the variables and what they represent. So here's what I want you to do. I want you to memorize that mu represents the mean for the population, right? And X bar represents the mean for the sample. So that's the first thing I want you guys to get. Get these guys down. Know the difference between X bar and mu. Once you get that down, the next thing I want you to get down is sigma squared and S squared. Know the difference between these two. These are both variance, right? These are both variance. But understand that this one is for the population and this one is for the sample. So know that down. And once you get that down, the last one I need you to know is it without the squared, right? Without the squared. And this right here represents the standard deviation. Know that down. Deviation. And again, this one is for the population standard deviation. This one right here is for the sample. So get those guys down, okay? And then we'll work more with the calculation stuff, and I'll show you the shortcut on Thursday, right? So that's gonna be it for today. And hopefully it wasn't too much. I know it was a lot of numbers and a lot of things I was yelling at you about, but hopefully it wasn't too bad. Don't submit the notes yet. We'll get into it. If you want to retake your quiz, I'll have my office hours today from 1 to 2. Just get in there early, guys, because I do have to leave early today. So get in there before 1:30 and I can reset it. I will not have office hours tomorrow on Wednesday. Just a heads up. I have to take my mom to the doctor's appointment tomorrow, so I won't have office hours tomorrow. So if you want to retake it, you can do it today or Thursday or Friday, okay? And other than that, guys, have a good rest of your day. I will see you guys on Thursday, unless I see you guys. And yes, Michael, you can retake on Thursday. Yes, you can retake on Thursday. You can retake on Friday. You can retake today. Other than that, guys, I'll see you guys later. right? Have a good rest of your day. All right, so long, guys. Bye, Demaya. You have a great day as well, Demaya. Have a good day, Oscar. You too. Bye, Christina. Have a great day. Bye, Jenny. You have a great day as well. Have a good day, Michael. So long, guys. Farewell.